So I think I can share the screen, and so we can start.
Yes.
Okay. Let me know if you can see the screen. Okay.
Yeah,
so
I should.
Thank you. Thank you. So thank you very much for being here today. Just a little background on I've been in the company twice. The first time in 2006 until 2012, and at the time I was the CTO of a contextual advertising company named Semantic. That was a spin-off of this of expert.ai. And then I came back 2 years ago, and I joined as a head of product innovation, and we are working hard to really make NLP easy for everybody. Okay, and I've been a coder since I was 11, probably. I started on paper, and the first experience was with a Commodore VIC-20 with a small bug and a syntax error. It was a funny story. In Italy, we have input with the NP, with the MP, okay, and in English is with the NP. So I was writing IMPUT, and it was INPUT, and it was syntax error. I didn't know why. And then I fixed my first bug, and it was 11 real. So anyway, good morning to the West Coast, and I'm in DC, so good afternoon to the East Coast, and good evening to the rest of the world, Europe, Asia, and who is connected today. Okay, today we'll see together how natural language understanding can be easily used in the educational field, for learning in a fun way. Okay, so let's imagine this scenario. I'm a kid in a primary school, and I am, for instance, I'm learning how the American Constitution was formed. And I find an interesting article on the internet, like the one I will show you now, that is from History for Kids. Here it is, where we have, very simple words and few lines of text. We can learn the foundation of the history events that brought us to the American Constitution. Okay. Okay, so but now the problem is that as a student or as a kid, I want to remember what I read. Okay, and I want to know what happens. I want to know who were the protagonists, which are the relevant concepts. Okay. And usually, we play with cards to memorize all this stuff. Well, another way to study this kind of information, and I'm talking about kids today, but in general, it can be applied to everything we want to learn. Okay, so we can transform the experience of learning into games, and of course, the idea is not new. Kids, of course, like to play, but usually these games, especially the approach of this game, is to use keywords, okay? And those keywords are taken from a list of keys or from pre-selecting topics, text, and stuff like that, okay? So what if instead we can apply NLU to every article that we have on the internet and trying to learn from those articles in a funny way. So today we are going to create a game, and I want to give you right now the takeaways that you will have at the end of this session. So first of all, how to apply natural language processing and natural language understanding in the learning field and in the gaming field. So what we say, gamification of learning. You will understand how easy it is to extract context from a text using our expert.ai API, using really very few lines of code. And you will see how to structure a program. Today we're going to use Python because I think most of you are data scientists or software developers, and probably Python is the easiest way to approach this problem today, also for a matter of time. And of course, we will learn how to make a game. Okay, so it's kind of a challenging, broad goal achievement. Okay, I anticipate, first of all, that the program is far from being perfect, and so for in order to fit the time schedule and not to bore you to death, okay, I'm not going to write every single line of code. I will do more a code review where I will uncomment and explain the code and see time to times what happens when we run it. Okay. There is no logging, no comments, no test, okay, in order to fit the time schedule. And if you want, on GitLab, you can see on the slide in PowerPoint at the bottom, you can find the code. So in the future, if you want to just fork and have fun, okay, changing the code or using other features of natural language processing for extending the application. Okay, so let's start. I will start now with the description of the game. Let me see here. We can go. Okay. Actually, I want the background here. Okay, so what we want to do today is something like this. We will take an article from internet. In this case, it's a very simple article, as you can see, about the American Constitution. Okay, and so this is going to be an HTML page. We will download the HTML page and we will scrape the content. Okay, so we can do scraping. And from the scraping, here we can put some images and so forth. From this scraping, okay, we extract the relevant text. So that usually we remove advertising, we remove banners or whatever is considered noise in the text. Then we will send this text to our API, okay, the expert.ai expert.ai API. And what we will have from there is a certain number of information, specifically for the scope of our game. We will have relevant concepts and we will have entities. Okay, so people names, we will have organizations, we will have locations, we will have dates and other entities from the one we can provide out of the box. And once we have this extraction, what we do is we create our game level that basically is a window where we will have a ship on top of this window that can slide left and right. And from the bottom up, the text that we extracted will start floating up. And this text will be composed by keys or from words and gaps. And the objective of the game is to literally drop words against this text to fill these gaps. And in the meanwhile, some of these words, they will be kind of enemies. And what they will do, they will drop up, in this case, some words in order to hit the ship. And the ship, in order to fill this gap, has every time has a load of 3 words. these three words will be here, okay? And pressing the keys 1, 2, or 3, we can decide which word to drop in order to fill a gap. Every time we fill a gap, we earn 1 point. If we are hit from a word coming from what we will call alien, the words, okay, we will lose a life. Okay, so this is the process, okay? As you can see, the NLP part is a small but relevant part of this development. Okay, so let's start and see. We will keep the question at the end, if you don't mind. And in the meanwhile, so just in case you really have something like a big mistake that you notice or something like that, I'm very happy if you can just tell me and fix it, okay? But otherwise, I ask you to wait for the end of this talk. Okay, so the first things we have to do when we start coding is to have a main function. So something where we can start our application. So what we are going to do here is we are going to remove the comments here. And as I said, time to time, we are going to test what is happening. So in order to run this game, we need a game. So we need an object. In this case, you can see the object is this object game. We are going to comment here. So we have this function main that will be called when we run this application. And the first things this application does is to create an object game. These two numbers represents, of course, the width and the height of the windows where we want to play the game. And this is the URL that we want to analyze. An interesting thing here is that if we have time at the end, we will see, but the idea is that you can actually start this game and in the meanwhile browsing, and when you find something interesting, you just use a bookmarklet, basically a bookmark in your preference bar, okay? So that you can click on the link. The link is sent to this game. The game keep the URL and download the HTML, scrape the HTML, extract the text, and prepare the game. There's only one thing I want to do here. Sorry. It's okay. I can do it. Okay. So in order to run this game, we need to create a class game. And for today, we are going to use the library Pygame. Okay, it's a very simple library, and you will see it's really easy to use. Okay, we go to line 6 here. Okay, and we uncomment this one. So now we are ready to create our game. Pygame needs to be initialized, and once the game is over, it needs to be quit. So here we have our first few lines of code that we need in order to run our game. So we have to initialize, and as you can see, we have to pass the width and the height of our window where we want our game to run. Then we need to initialize some constants and some default value like the screen and the colors. Okay, so I will uncomment this, and we're going to see in a moment what these things do. And another things we have to do is to initialize the stage. In this case, we want to initialize the stage just for the game loop. We will see that every game has a game loop, okay? And the game loop usually ends when you have a game over, Okay, so in the initialization stage, at the very beginning, we need just a variable game over to exit in case we want to just quit the game, or if something happened and we have to we died or whatever the reason the game is over. Okay, the next things we see here is to initialize the screen. So Pygame needs some initialization. So we need to specify the windows that we want to use, and specifically the width and the height. We can also go full screen, okay, but for the purpose of today meeting, we're not going there. And another important thing that Pygame needs is a clock. Okay, I don't know who is a gamer, but usually you have the concept of frame per second. Okay, you want to control how many frames your game is going to play. But otherwise, the risk is that it's too slow or it's too fast, and so you cannot really follow the game. Sometimes it becomes it's kind of glittery and stuff like that. Next things, we want to initialize some colors. Okay, very easy here. You can basically recognize we are using an RGB notation, red, green, and blue. And basically we mix these three values to create new colors. So for example, yellow is basically full red, full green. And this is something that we learned when we were at the elementary school, probably. And the same for orange. Okay, of course, a little bit less of green, because we don't want yellow, but we want something more reddish. And the next, we want to initialize some constants. For now, we are going to initialize only the frame per second, so that we are able to run the game smoothly. And then we need to initialize the stage. Okay, so here we are. We can initialize the stage, and the only things we need here is this line for now. So we want to be sure that we're able to control when the game is over. And now we need to play the game. Okay, so we basically set up everything we need to start playing. And the next part is to play the game. So you see, we need to go here. We have this method play, okay? And what we want to do in the play is to start the game loop. I'm going to enable only part of the loop. So basically you can recognize here that generally speaking, then there are options, but generally speaking, a game is composed by three different moments that are continuously running. Okay, so the first things you do is to check your input, in this case the keyboard, but it can be a joystick, a wheel, according to the game that you're playing. Okay, so you want to control the events of your games. Then you have an update that basically moves all the actors in the stage. So it's the logic of the game. And then you have a render manager in this case that actually draw everything on the stage. And so we need now to see how the event manager and the render manager are composed. So I'm going to line 254. I hope this doesn't annoy you if I'm going up and down, but for some reason, I need to check. Oh, okay. Control G works, sorry. So I will go with Control G, so I will avoid this kind of annoying movement. Okay, so the event manager is here, and for now, what we are interested in is these few lines of code here, okay? So what we want basically to do is to get the event coming from, in this case, the keyboard, okay? And we want to intercept when we control quit the game. And you can see that when we control quit, the loop ends with the self.gameover becomes true, and the application just exits, okay? Okay, next we need to go to the render manager. Okay, so we will switch to line 354. Okay, here. And what we need for now is just, so I'm going to uncomment this part and basically the last part here at the end. Okay, and we will see why. So what we are doing here is to say, okay, after drawing everything, okay, update the display. So what we are going to do is to prepare all the graphics, and when everything is on the stage behind the scene, okay, we say, okay, now you can visualize the game. Okay, and then what we do is we use this tick to slow down or accelerate our frame rate, okay, so that the experience of the game is constant in time. Okay, and in this case, 60 frames per second. Then we have this helper here that just allows us to slow a little bit down the clock. Okay, and we will use it for avoiding object to be too fast or too slow. We will see later. Okay, so we are ready to run the game. Okay, so let's try and see what happened. Okay. Okay, here is the game. Of course, there's nothing because we didn't actually put anything in the game, but at least we have a window, okay? And we have a black screen, and you can see here, we have an hello from Pygame community. The application didn't crash, so we are positive, it works. So let's now add something more. Okay, next thing, we want to add a background. In order to add background, we need what we call assets. So assets are images, are sounds, are fonts, okay, that we usually have in folder assets, and allows you to give a little bit of color to the game. Okay, in this case, we have a folder where we have different objects. I will show you what we have inside. Hold on. Okay. Okay, you can see here, this is the folder asset. And in this case, we have a background that is the image that we are going to use for our game. We have a font that in this case is a pixel art font, we will see. Then we have some sound we can play. Okay, this is an example. Let me know if you can hear the music, please. And we have a soundtrack, okay, that we will use as a background music for the game. Okay, so this is our assets folder. So in order to use the assets, we need to load them, okay, and we need to initialize them. So if we go to this line, okay, here, we have self-initialize assets. So what we do is we do this, okay, so now the assets are ready, and we go here where we have our assets, and for now, we are going to enable just the background image, okay? And let me see. Okay, and then we need to show the background, okay? So here you see that we have this line. We use the screen that we previously created when we initialized the Pygame, and this function basically draw the image at coordinate 0, 0. So if we uncomment this, we have what we want. And now if we run this, okay. Let's see. Okay, sorry. I have to check where we are. Okay, now it's better. Okay, and as you can see, now we have a background. Okay, now next things we want to add is some score and lives, okay, so that we want to check how our game is going. So let's close the game. We go here. Okay, so we need a score, and we need some lives, and we need to initialize also a border space, just because we want the score not to stay all the left, to the border, to the edge of the window, and so we go up in here, okay, and we enable this one. Okay. Next things we want to do is to load in our assets also the fonts. Okay, so we have here our line when we create our fonts, and you see how easy it is to create a font. So we just basically point to the folder asset, and we load the font there. Okay. Next things we want to draw actually on the screen this text, and we have to go in the rendering function, right? Okay, and so what we have to uncomment here is these two lines, this one and this one. Okay, and if we run now the code, okay, you can see that here we have score 0, lives 3. Okay, let's go ahead. Now, next things we want to do is we want to have a laser line. So we want our text to move from bottom up, okay, but at certain point just be wiped out by a laser, okay. So at certain point the player, the gamer, has no more chances to fill a gap, because that gap disappears if you are not fast enough to do it. And in order to do this, we need to enable two things. One thing is here, you see that there's a draw line. So we want to print in the screen where we are playing the game, a blue line. And so I can uncomment this. But in order for this to work, we need to establish where we want the laser, so at which height we want the laser to work. And in order to do this, we have to go back here, and here we have this line to uncomment. That's pretty straightforward, okay? And now, if we play the game, you see that we have this blue line here, and so every time our text overcome this blue line, the text just disappears. Okay. Next thing is the ship. Okay, we want this ship to float on top of the screen, and then we want the ship to move left and right. So let's see what we can do. Oh, sorry. Okay. Okay. So we need to define a class shape. This class shape is basically a class that is common to everything that we will draw on the screen, and basically it provides with an X coordinate, a Y coordinate, and an object game that allows us to have access to colors and assets. Okay. So what we can do here is we can basically uncomment everything that we have here. Okay, and then we have to uncomment something here where we define the shape. Okay, the shape is basically a shape, and so we initialize this shape as a shape, but we need to load an image. Here it is. Okay, we need to rescale the image so that it becomes small enough to fit correctly in the screen, and we have to define a couple of variables. The speed is going to be the speed the ship has when it moves left and right, and load is basically the number of words, okay, not the number, it's the words that the ship will carry that will be dropped against the gaps. Okay. Okay, so Next, we need to draw the ship. So usually when we use images, we have inside these classes a function draw, so that take care basically of the drawing of the, in this case, of the image of the ship. Okay, so we need to uncomment this first line here. That is where we define the draw function, and this that basically draw the image of this of the ship on the screen. Okay, next we need to create a ship. So we need to go here. Okay, here we need to create a ship when we initialize the stage. Okay, in the stage start, and on the stage we need to put a ship. And as you can see, we put the ship in the middle of the screen. Okay, at the height of 10 pixels from the top. Okay. Next, we need to actually draw the ship where in the rendering loop. Okay, here we have the ship drawing. Okay, last, for the ship, we need to control the movement of the ship. Okay, so we need to go to the event manager, and we need to uncomment the part that allows the ship to move. And specifically this one. As you can see, what I check is that I ask Pygame to give me the list of keys that I pressed, and I check which keys I actually have pressed. The left keys, the right keys, and what I'm doing is basically move the position, the X position of the ship, okay, on the left or on the right according to the speed of the ship. So if we run now this, you will see that we will be able to move our ship left and right. Okay, so we are going there. Oh, now finally, okay, we introduced the natural language processing, because now what we have to do is to create this text with gaps and enemies, shooting or floating words against you. Okay, we need to create those that text, and we need to create the load of our ship. So the 3 words that we can drop in order to fill the gaps. Okay, let's see now how our technology works. And I have here a second. Okay, so in the website developer.expert.ai, you have access to the demo where you can basically experiment everything you can do with the expert.ai API. So what I did here is I took basically a couple of paragraphs of this article, okay, and I copy and paste it in here. So let's see what are the capabilities of this API, and let's see how easy it is to use those API for this game, but in general for every natural language understanding application. So we analyzed this text. And okay, now I want to show you what happens behind the scene. Okay, I'm going to enable this part, okay, and I'm going to describe you what is happening here. Remember where I put the, oh, here, sorry. Okay, we will use again this drawing board. So what happens here is that, first of all, there's the classic NLP pipeline, okay? So I will draw here NLP pipeline. So first things we do is to split the text into sentences, okay? So we do it sentence splitting. After splitting the text, we tokenize it. Okay, so we basically reduce the sentence into atoms of words, and some atoms in reality stays together. And you can see here, there are multiple examples, like declaration of independence, okay? That is considered like a single word, even though it's composed by three actual words. And we call this collocation or compound. Another famous example is a credit card. Okay, so we can have here tokenization. After the tokenization, what we want to do is to find the base form of every single word so that we can transform what is singular, what is plural to singular, what is a verb in the past to a verb in the infinite form, and so forth. So we have what we call lemmatization. And if we actually click on one of these words, let's see here, okay, you can see that, oh, sorry, not this one, colonies, this is plural, and the lemma is colonist, okay? Same for declared, okay? You can see that the verb is a past tense, okay? And you have declare as infinite form, okay? This is the lemmatization. Next things that happens is the part of speech tagging. So now that we have the token, now that we have the base form of these tokens, what we do is we do part of speech tagging. What is part of speech tagging? Part of speech tagging is basically assigning to every single word a grammar type, so that we can, split between nouns, verbs, adjectives, adverbs, punctuation, and conjunction, and so forth. Okay, this is important because we could be interested just on nouns, for example. If we want to create a tag cloud with specific nouns that we are targeting, okay, this is a way to just filter out everything that is not a noun. Next things we do is to create what we call, what in natural language processing is named dependency parcel. So you see that we have all these nodes and all these edges between nodes, okay, and they have a label. So we basically do, we structure a sentence, okay, according to the logic of the sentence. So you will see that there's usually a root. In this case, it's here, okay? And this root usually, but not necessarily, usually is a verb, is the main verb in the sentence. And then you have, like in this case, you have subjects, okay? In this case, the American colonies, particularly the colonies. And you have an object, independence. So the dependency parser generates a dependency tree. And the dependency tree is very important to find relations, okay? We will see later here, okay? You can basically find not only relation that we call subject, action, object, so who did what, but other kind of relation like when he did, where he did, how he did, and why he did, okay? Usually we cover, according to specific cases, we cover all the W, okay, that we know. Okay, so here we have dependency parsing. Okay, next, what we do, and this is kind of peculiar of our technology, is we do a full disambiguation. What it means is that we assign to every single token in our sentences a meaning. And this meaning comes from a semantic network. Just to be very simple, a semantic network is a graph where nodes represent concepts and edges represent relations between these concepts. So for example, we can have a node representing the concept of transportation, and a car is a type of transportation. And an SUV or a pickup, okay, they are type of cars. So you see that there's an hierarchy between those concepts, okay? And we can have multiple type of relations, okay? In this case, we have a relation we call technically hyponyms or hyperonyms, according to if we are going down or up in the hierarchy. But if we want, for example, to specify a wheel, okay, we have another concept here that is named wheel. We can link this wheel with car as a part of a car. Okay, we call it meronyms from Greek meros, that is part of something. Okay. So this is the disambiguation. And we can see that the disambiguation is available. And if we, for example, check American, okay, you see that there is a label, nationality. So it means that in our semantic network, American is connected to nationality. And in fact, is correct. American is, to be American. So the nation you belong to. And you see colonies is a type of person that is an inhabitant. Okay. So, and this is applicable to everything that we have here in our text, in our content. Okay. And this is the power of our technology, because thanks to this concept, okay, we can create very sophisticated heuristics, okay, to extract specific entities or to classify specific text according to some taxonomy. And we can also use the same technology to label data set in order to create a training set for machine learning, so traditional machine learning algorithms. Okay, so this was the really 5 minutes description of how the technology works. Let's see now what we get from our request, so from our JSON that we have back when we call this API. Okay, I will clear the screen here. And okay, so first of all, we get the key elements. Okay, so here, for example, we have, and we will use this in the game, we will use the main concept. Okay, as you can see, government, declaration of independence, free state, citizen, I'm jumping, okay, but those are relevant concepts that are present inside the text, okay? And because of the disambiguation, it's easier and more effective to determine which concept is relevant and which is not. Okay, with the same criteria, we can extract main lemmas. So basically, keywords reduced to base form, where there's still some polysemy. Okay, so where you can have some ambiguity because of the concept of lemma. And you can also have the most relevant sentences. So if you want, for example, summarize quickly your the content of your text, you just use these 3 sentences that basically represent the most important part of your content. And the same apply to the main phrases. So you saw in the previous presentation of the text that some words were grouped together, okay? And those groups represent a more contextual sequence of words, okay? So one thing is to, let me go back here in the disambiguation, okay? You see that, for example, during the American Revolutionary War, okay, this is considered a phrase because it gives you kind of a context of what is happening, okay? Just the American or Revolutionary War is not enough. So you know that is during something, so it's a temporal thing, okay? Okay, let's go now to check the entities. So we can extract, of course, entities. The most common are people, organization, location, but out of the box, you can also have dates, you have In this case, you see administrative geographical area. It's not just the location, but also other geographical data coming from geonames, for example. Okay, and I forgot to mention that most of these concepts are mapped on linked data through Wikipedia, Wikidata, DBpedia, and so forth. Okay, next we have classification. So we can use the disambiguation we talked before to extract, based on specific taxonomy that we want to use, what this article is talking about. Okay, in this case, we are talking about war. We are using the IPTC media topics. I don't know if you're familiar with this taxonomy. In this case, it's the International Press for Telecommunication Council taxonomy. I think there are more than 1,000 categories organized in a hierarchy of 5 levels. Okay, and basically, we are able to extract every single category. And you can understand that doing these things using traditional machine learning is kind of a challenge, not only because of the deepness, okay, of the depth, sorry, of this taxonomy, but also for the number of examples that you need in order to train such a deep taxonomy. Okay, next thing is the relation. So using the dependency parser, we can create this kind of representation where we can just see in one single shot colonies declare independence. So you see subject and object, so who did what, the reason, okay, sorry, in this case, from where, so that from who they declared the independence, England, and when, during the Revolutionary War, specifically July 4, 1776. Last but not least, we can determine sentiment. In this case, the sentiment is slightly positive because, yes, we are talking about war, but we are also talking about unite, independence, okay? We are talking about constitution and law right that are generally speaking positive words. Okay, so this is a kind of a description of what the API is able to do. We can see now the output of this API is a very easy to read and to parse JSON. Okay, and in this case we have the disambiguation. We can just close the knowledge where you can basically map an ID that is assigned. Every number that you see with the name Syncon represent the ID of a concept inside the semantic network. Okay, and this label is basically an abbreviation of the gloss, okay, of the definition of the concept represented by this number. Okay, and we can see here we have the tokens, okay, and you see that basically here you have everything you need to build the same graph that we saw here in the disambiguation. Okay, so let's see now how we can use these things to for our game. Okay, there's still something. We'll see if we are going too long. We'll just skip to the end and show how the games works, because this is the most relevant part, of course, of the talk today. But I mean, it's also interesting to see how to play the game at the end. Okay, so let's quit here and let's go back now to our API. Okay, so next things we have to do is to enable the NLP. Let's jump to row 96. Okay, and you see here we have this comment. We remove the comment, and you see that we can initialize the natural language processing, and we can pass a URL in this case. Okay, so what we have to do, as we said at the beginning, we need to download the HTML associated with this URL. We need to clean the HTML, extract the plain text, and process the text with our API. Okay, so let's jump now to some imports that we need in order for the API to work. We go here at the beginning. Here we are. We can uncomment all this part. And you can see that we are going to use, two different libraries. One library is Goose that you can find is a Python library that allows you to extract text from an HTML. And then you find the expert.ai API. If we go back to the website, let me check here. Okay, you can find this if you log in into the developer portal, you go to developer, you have natural language API here. You see that there's an SDK and you can select Python. You can do this in Java or you can do in whatever language you want, because at the end of the day, these are helpers to give you the data model without you to parse the JSON and extract these fields by your own. Okay, so here you have access directly to this API. It's very easy to install it. You have to use just the pip like you do for normal Python libraries. Okay, let's go back here. So now we need to initialize this NLP. Let's jump. Okay. Let's see what happens here. So what we try to do here is to create an hash code of the URL so that, especially if we need to play the game multiple times, we avoid to call the API every time providing the same page. Okay, it's just a way to cache the result so that you don't waste characters, okay, that you have available on the API. So the business model is based on the number of characters that you consume, okay, and so there are 10 millions of characters that you can use, okay, before having like a before you need to subscribe and so pay for a fee for using the API. So you have 10 million characters you can use for free. And in order to avoid, again, to waste these characters, what we do here is we basically try first to check if we already downloaded that specific URL. And so if we did it, we don't need to call the API again. Next, we use Goose, very simple. We ask for Goose, an instance of Goose. We use this extract where we pass the URL. And the output is this text. That is basically the clean text. And this is the text that we are going to use for using our API. Okay. Next, what we have to do is we uncomment this. Okay, this is basically the heart of our API. And you see there are literally 5 lines of code. Okay, so in 5 lines of code, you can do a full analysis. So have in one single JSON everything that you saw before in the demo. Okay. So what we are basically doing here, we instantiate a client that knows where the service is. We already have a couple of environmental variables that we need for username and password so that we can authenticate to the server. And we use basically the same credentials that we use for logging the portal. Okay. And once we have the output, what we need to do is to extract from the output only what we need for the game. And we anticipated at the beginning that what we are going to need for this are the entities, so people, organization, location, dates, and products, and whatever is available, the email addresses, telephone numbers. Okay, there are a certain number of entities that comes out of the box with this API. Okay, for the other entities, you can use another tool named expert.ai Studio that allows you to create extraction rules, and so you can customize what kind of entities you want to extract. Okay, so what we need for the purpose of our game, we need only to extract the entities. And you can see that we have inside the entities a field lemma where the entity is stored. And we need to extract the main concept. Okay, and again, we have a field lemma to extract this concept. So we remove these two lines of code. And we put together the list of the two things, because these are the objects that we are going to use in our games. Okay. Next things, we create a different structure that we want to save, so that again, if we want to replay the same game with the same page, we don't need to recall the API again. So what we are basically doing here is we are looping against the against the tokens, okay? And we created this new JSON structure where we have term, where we basically take the original text and we use the token to determine where the text starts and when the text ends for a specific token. And we specify the type that can be known or relevant according if the token belongs or not to the relevant list that we created here. And then what we do, we save it so that in the future we don't need to recreate it again. Okay. Let's see if we can use the debugger now here. I stopped the debugger here so that we can see if we can actually see what is the value that we provide at this point. Oh, sorry, no, but there's a reason. Let me, because I think if we go inside the temp, okay, we already have this this JSON. Okay, let me remove it. Okay, and so now the system will run the actual call to the. Okay, I knew this would happen. So if you don't mind, I will move the windows here so that you cannot see where me entering my credential, and then I will share again the windows. It's going to be very fast. Done. And here we are. So now let's try again. Oh, all this smoke, sorry, here. We need to debug. Is it too late? Yes, it's too late. Now it should be, oh, why I continue to do this? Okay. Sorry for that. Missing username and variables, that's correct too, because we are in the debugger now, and before I was not in the debugger. So let me again hide this. I should be able to stop it. Okay. Again, sorry for this inconvenience, but it's going to be very fast. Here we are. And hopefully this time is the right time. Okay, here we are. So I will open the full screen so that we can see better. Okay, what we can see here is the output. That is the output provided by the API. And we can see here that we have entities, that this is what we want to extract. And we see that we have the lemma, in this case, a date, 1933, and we have the type that is actually a date. And let's see if something else. This is another date. You see, Second Continental Congress is an organization. Okay, so sometimes the entities are recognized because they are in the semantic network. Sometimes they are recognized because of the pattern. Okay, they have inside the content. Okay, so you can extract these entities in two different ways, basically. Okay, but this is kind of behind the scenes, so you don't really see what happens in reality. Okay, so this was just to show you how to use our API and what is the output that you can use. Let's see also the tokens. That is the other things that we need today. And here it is, tokens, here it is. Okay, and you can see that we have for every single token exactly the same thing that we were saying in the API. American is an adjective, and we can see the lemma is American, and the syncon is 9700, and if we go to in the knowledge, we will see that 19700 is it's a little bit tricky now, so I don't have enough time now to show you everything, so we will skip this part if you don't mind, because it's already 1 hour. And let me know if we are running late, because Murat especially is already an hour. I still have something, of course, to show, because the game is not ready yet. But let me know if we have to just rush a little bit. I can just jump to whatever you want, okay? Okay, so let's stop now this debugger, and let's go back to our game. Okay. Oh, now we have the fun. So we need to add the aliens, okay? So let's first initialize the level in the full way, okay, almost the full way. So let's go to line 384. So let's see here. Okay, here we need to initialize the level. Once we initialize the level, we need to uncomment also the level initialization. Let's see what this means. Okay, first things we do is we uncomment this part. Okay, in this part, what we do is we create the aliens starting from the tokens that we created using our API. Okay, so in order to do this, we need to create the class alien. We have the class alien here. Here it is. Okay, and we prepare the alien this way. So you see that here, what we do is we basically have two variables where we initialize our alien. One is the value that is going to be assigned to the alien. That is the one we will see in the UI. And the true value is the real value. So if this is going to be a gap, you will see in the value, basically the underscore. And in the true value, you will see the real value. So when we will drop a word, the word will intercept this alien. And if the word associated to that drop is the same as the true value, then you hit the point. I'm going to uncomment just other things so that we are ready to just, because again, we don't have really a lot of time. So I'm going to skip some of the things that I was doing before. So next we need to draw these aliens. So what we do is we decide the color. We will see that the enemy can be hit or they can hit. According to the role that they have, they will be red or green. Okay, and here we need to render the text. Here is where we draw actually the text, and we need to determine the rectangle, because when we need to check the collision between an alien and the ship, or the alien and the drop, we need to know what is the rectangle that each of these actors, okay, is occupying. Okay, so next things we have to do is to enable some variables that we need for, okay, here we have alien space, alien speed. So these are two variables that allows you to decide which is the distance between two tokens, one's next to the other, and the speed is the way the text is going to go up, so bottom up. Okay, we will see in a while. Okay, and then we need to enable the list of the aliens, okay, because we will have every token that will be represented by an alien. I'm trying to speeding up a little bit. Okay, so we have these aliens that will contain the list of the aliens that we are going to draw in the screen. And next, we have to draw actually the alien. Okay, so let's go here. And you see here, we have this part where we loop over the aliens. And if the aliens are not hidden, we will see later why they are hidden, we can draw them. Okay, let's see what happens now. If we run the game is here. Okay, nothing happened. Why nothing happened? Because we need to move those aliens now. Okay, they are at the bottom of the page, so you cannot see them. So let's see how we can move those aliens. Okay. So we need to go to the we need to add a new thing to the game loop, and this is the line we have to add. So now we need to update the scene so that everything in the on the stage move. And next things we have to do is to define this update manager. Here we are. So what we can do for now is we can uncomment this part. In a second, I want to check. Okay, 282. Okay, here we need to prepare this. And sorry, this is early. Okay, here. Okay. Next, we need to position this alien, okay? And so we need not only to put this alien one next to each other, but because these aliens are going bottom up, okay, we need to change also the Y position. So we need to change both the X and the Y position. So we will basically uncomment this until here. 306, yes. So here to here. Okay. Last things, we need to determine the movement of this text. So let's go here. And oh no, we already have defined the alien speed. Perfect. So let's see now what happens. And voila, we have our content moving bottom up. Okay. Now we need to generate these gaps and the enemies. Okay, let's first create the gaps. So I stop the game. Let's go here. We go to here. So we extract the relevance from our list, now the list that we created, the ones we call the API. And to call them, we just need to filter from the tokens the one with the type relevant. And then what we can do is to start, yes, what we do is we generate a random number between a start position starting from 0 and 3. This is a random. I mean, it's you can see here there's a comment to the line you can use the level of the game to decide how many gaps you want in nearby. Okay, so we use these lines of code to generate which word is going to be a gap. And you see that when I decide that word token is a gap, I assign to the value an underscore, and I enable the where is it, the real value. Well, the real value, we already defined the real value when we defined the alien. Okay, so and here what we do here is we basically create already the triple words that we were going to use on the ship. So here in this loop, you see here terms for in range 2. Here we are basically taking from the relevant list randomly two relevant words, and then we had the real word, the real term. And then we shuffle these 3 terms so that at least one of the 3 is a solution for our gap, and the other 2 are just randomly taken from the token list. Okay, and you see that we have a bucket here that we have to use to put these words. Okay, when we load these words in the ship. Okay, so we are almost there. Eh? Yes, we are almost done. Let me see. Okay, so now we need to create the bucket. So we go up, we go here. Sorry. Okay. Let's create this gap. Okay. Let's play. Okay, you see now that we have these. Okay, the ship moves. Okay, hold on a second. I have to check one thing. Okay. It's in here. Okay. Okay, so next things we have to do is to load the 3 relevant words so that we can start dropping these words and fill the gaps. Okay, let's go to the line 28. Okay, so we need, of course, when we add the load to the ship, the height of the ship changes. And so in order to put these words in the right order and in the right height, we need to create a method that allows us to determine which is the maximum height that we need for the sprite. This is also important, we'll see for the collision. Okay, even though the collision is going to involve only the ship and not the words. Okay, next we need to enable the drawing of these words. So we uncomment this part. And here we see that basically what we do is we use the height of the image as a starting point from where to start drawing the words that we pass here as a load. You see that in the definition of the shape, we have load that at the beginning is empty. Okay, when we initialize the level, we pass basically the first 3 words here to the ship, and this is the way we are drawing these 3 words. Okay, so we are taking we are using the stage font that we defined at the very beginning, and we assign an orange color, and this is the word that we want to print. We want to align this because it must be center respect to the ship, and then we can print or draw it in the screen, and then we update, we increment this I so that every word is stacked one on each other. Okay, and next is okay. So now what we have to do is to basically print these words here. Sorry, print. We need to update. So what we are doing here is we, hold on a second. Yes, we check if the load is empty. So if the load is empty, we load the bucket. We load the ship with the bucket that we created at the very beginning. So you remember that we have the buckets. Every bucket contains 3 words. We start with the first bucket here, and every time we basically remove the first item. And so we always, you see that here, we basically remove the first item. So every time the next triple is going to be at the top of the list. Okay. Hold on a second. I need to. Oh, this is a problem. Okay. Next things, we need to use the events. Where is it? Events manager, here it is, okay. So what we are doing here is to now to check if we are hitting the key 1, key 2, or key 3. So if we are pressing actually the keys 1, 2, and 3. I'm going to speed up a little bit because I see that it's really late. Okay, so and once we have this, we need to update the drawing, so the rendering manager here, because we need to see the aliens. Sorry, we need to see the drops here. Okay, and okay, let me see if it goes. Oh. Yes, in fact, this is early. Sorry. Okay, and you see that we have now our words. And now, of course, we cannot drop them yet because we need to create our drop object. Okay, now I will uncomment a little bit more so that we are going fast to the conclusion, because I think I bored you enough. So a drop is basically a container of a word, and the drop can go from top to bottom or the other way around. So from top to bottom is when the ship drop a word. From bottom up, when an enemy or an alien, okay, kind of shoot against you, against the ship. So we will uncomment this. And as you can see, what we are basically doing is, again, to determine the rectangle that we need for checking the collision between the drop and an alien. Okay, so let's keep this for now commented. Okay, and we need to update the drops. Down here. Okay, here we need to call this function drop. We remove the sound. We don't need the sound. So here is where we actually created the drop, and we appended the drop to the list of drops. And I think I need to enable also here the drops. Okay, I need to add the drop speed because I want to manage how fast is the drop when it falls. And I need to create this drop container. Okay, I will uncomment these two, and we will prepare the enemies so that we will be ready when we need. And I will explain later what the enemies is. It's basically a token that start from the bottom and try to shoot the ship. Okay, so next thing we need to do, we will check later all these collisions, okay? But we need to update these drops, okay? You see here, and drops must fall. So here, what we are going to do is to loop over the drops, and we change the position, the Y position of the drops according to their speed, so they are going down. And when they disappear, when they arrive at the bottom, we remove them, because otherwise we will generate infinite drops, and we could end up with an out of memory. And when this word arrive at the end of the bottom of this of the screen, we want the ship to be reloaded with that word. So if it arrives to the end of the screen, it means that it didn't hit any gap, or at least it was wrong. And so you basically reload your load. Okay, and then we have to draw these drops. Okay, so now I can move, and if I click, you see that I can drop these words. Okay, now we need to collide. We need to check the collision with the gaps or with other words, so that we know if we fill the right gap or not. So in order to do this, we need to enable the collisions. Okay, so here we have a couple of functions here. Okay, so this is the functions that check if two objects on the screen actually collides, and you see that we use the rectangle that we define in every single token that we have. Here, what we are going to do is to check if there is a collision between a drops, so between a word dropped by the ship and one of the word in the text below. Okay, and if something happened, these two values are returned: the name of the drop and the alien, so that we can check if actually are meaningful for the point of the game. So if we go here in the update, okay, we don't need this, we need this, okay? We need to check the collision between the aliens and the drops. So in the update now, every time we update the game, we need to loop over these aliens and drops, and we need to check if these two values are not none. It means that there is a couple, drop alien, which intersect to each other. Okay, and so what we do is we check if the value of the drop is the same of the true value of the alien, because remember that a gap, in the value of the gap, there's an underscore. So we are checking if you are actually filling the right gap. And if it's true, if it's okay, there's a sound that for now we don't use. What we do, we remove the drop. So again, because we don't want this list of drops to grow uncontrolled. And then we add 1 point to the score, okay? And we replace the value, the underscore, with the actual word. And we say that the alien at that point is hit. So we can change the color of the alien in the text. Now we're going to see. And then we reset the ship load so that we can pass to the next token, so to the next triple that we prepared during the initialization of the game. So there is just one thing that I have to change in the ship, sorry, in the alien. I think it's here in the draw. Okay, this part. No, it's not this part. In the drop. Oh, it's already. Okay, let's see what happened here. Okay, now we can drop this. And you see that if we fill the gap, England is correct, it becomes green. It means that we fill the right gap, and the score now is 1. Okay, I will add now the sounds, and I will show you how the enemies can shoot at you. Okay, and then the game is basically over. Okay, so let's go here, and we have basically to uncomment the rest of the code here. So what we have here is in the drawer of the drop. Here we were drawing the drops going top down. Here we need to cover the alien that goes bottom up. Just to draw something and show you, what we are going to do is something like this. We said in our game, now we have these words that are going up. Some words that we call enemies, okay, they spawn their own and they try to eat you here. Okay, so you have not only to fill the gap, but you have to avoid these enemies. Okay, let's go pretty fast. We are basically done. Okay. We need the speed of the enemies. You see that the speed of the enemies is higher because we want these words to run pretty fast from the bottom up. Okay, I'm going to enable also the sounds. As you can see, it's very easy. I use the object Pygame Mixer, and again I have access to the assets folder where I can upload some of the sounds that you're going to hear. Okay, next things we have to do is down here. We want to spawn. We want to spawn these this enemy. As you can see, this was if you remember, this is the initialization level, and we were using the tokens to create the gaps. Okay, now we use a very similar loop, as you can see here, okay, to decide which word is instead an enemy. So which word is going to shoot the ship, being in any case a relevant type. Okay, now we have this manage the collision between these drops coming from the enemies with the ship that we control. And this is the music that we are going to play when a drop is shot. And we go down here. We need now to loop over the enemies to move them, no? And so that they are going, in this case, up with the speed, enemy speed. Here it is. And we want to play a sound if this word hit the ship. And here is where we control. Here is where we control actually the collision between the ship and a word sent by an alien. So this is the alien that has been that shot against the ship and hit actually the ship. So if someone hit the ship, okay, alien is not known, then what happens is that you remove the enemies, okay, because you want to remove it from the screen, and you lose a life. And of course, if the lives are 0, the game is over, you're done. And here we need to spawn the words. So again, we are in the update. What we are going to do is we initialize this alien counter randomly, and so we randomly spawn these words coming from the text. We are almost there. Here is the code to draw the first alien, and this is the code to draw the enemies. So these words that goes from bottom up, and this is the music. This is the background music. Okay, this sort of soundtrack, and basically the game is over. So let's see now if I didn't commit any other mistake. This should work. Where is it? Oh, here, sorry. Okay, and so now I can okay, we wait for just one word to be shot, and basically we are here. Okay, I've been hit. You see that the lives now are 2, and basically this is it. Okay, so thank you very much. I hope you enjoyed. It's been 1 hour and a half. I'm sorry for that, but I mean, I hope it was fun. It's not just to see how NLP works, but also how to create a game.